Okay, today we're going to keep talking about more special lines in a triangle, and specifically we're going to talk about angle bisectors and medians. So let's start with the angle bisector. We've talked about angle bisectors before. You should know that an angle bisector divides an angle into two congruent angles. Okay, bisect, cuts it in half. So what we're talking about though are angle bisectors in triangles. And that's simply a segment from the vertex that divides the vertex angle into two congruent angles. So for instance, here's one vertex angle here, and this is the angle bisector that divides it into two congruent angles, excuse me. Now what I want you to do is draw your own triangle. It doesn't have to look like this. It can be any kind of triangle you want. And then I want you to get a protractor and measure your angle and draw in your angle bisectors. We're not going to construct them this time. We're going to actually measure them and draw them in. Remember how we could construct them using a compass? Well, this time you could just get to use a protractor. Now again, the way to use a protractor, line up your vertex with that center area right here. This protractor has a little line there. You might have a hole in your protractor, but line that up on the vertex and then line one side of your angle, one leg of your triangle up so it matches 0. Okay? And then see where it hits up here. Well, this angle, it's right about 30 degrees. You see that? Right about 30 degrees. So half of 30 is 15. So to draw a mark right here, here's 15. So draw a mark right there, and then use a straight edge to connect the vertex with that mark and draw your line, and that's how you can draw your angle bisectors. Okay, now do that for all of your vertices. Now you might have to turn your protractor upside down, as in this case, for this angle to measure it. Okay, there's our vertex, and look, it comes right up here at 110, right at 110. So its halfway mark is right at 55, it's right about here. And then you draw, just line it up and draw your angle bisector. Okay? Do that for all three of your vertices, bisect your angles. And then we'll talk about what the intersection of those three lines are. It's called the incenter. So this point right here, where all three of your angle bisectors intersect, is called the incenter. And what's cool about the incenter is it's actually the center of a circle that is inscribed in the triangle. And I'll show you in a GeoGebra file what that means. But this is the center of the circle that's inside, and each side of the triangle touches that center, touches that circle. So that makes it superpower that it is equidistance. This incenter is the same distance from the sides of the triangle. So this is the same distance as this is the same distance as that. Okay, and we have a theorem to go with the angle bisector, which states if a point is on the bisector of an angle, so say MP, right, MP is a bisector of this angle, LMN, then any point on this ray is the same distance, equal distance, from the sides of the angle. So even if I picked a point here, and distance is measured perpendicularly, so it has to be perpendicular distance. So that would mean that that segment is congruent to that segment, this segment is congruent to that segment. So given that MP is the angle bisector of angle LMN, then we know that the measure of PN is equal to the measure of PL. And the converse is also true. If a point is equidistant from the sides of an angle, so some other point, and it happens to be equal distance, then we know that that is on the angle bisector. So if we are given that PL equals NP, which means the measure of segment PL, and the measure is congruent to is equal to the measure of the segment PN, then we know that MP is the angle bisector of angle LMN. So we can use this algebraically. And actually, I'll show you a picture when we're back in class maybe. We actually use this kind of configuration. Those of you who play baseball or softball may recognize this as like home plate and second base. And you know that all the bases are equal from each other, right? What are they, 60 feet? I guess it depends on baseball versus softball. So that's how they can tell. They actually use the angle bisector to make sure that second base is the same distance from first base as it is from third base. Isn't that cool? But we can also do some algebra with this information. Okay, so for instance, if we're given that YU is the angle bisector of angle Y, and we're asked to find angle ZYU, excuse me, this angle, if we're given that ZYU is 4x plus 30 and UYW, there's not a W there, should be a W, is 2x plus 40. Well, these two angles are congruent to each other, so you set up these expressions to be equal to each other. Do the math, subtract 2x from both sides, get 2x, subtract 2x from both sides because of this 2x. Then subtract 30 from both sides because of this 30. You get 2x equals 10, or x equals 5. Then just put 5 in for the measure of ZYU, which is 4 times x, which is 5, plus 30, or 20 plus 30, which equals 50. So that would be the measure of this angle. Okay, now let's use the converse. If we find the length, to find the lengths of PS and RS, okay, we're told by the picture that these two angles are congruent, so we know that this is the angle bisector, so we know that these two segments are congruent, and their measures are equal. So we're given that PS is 4x minus 50, and RS is 2x plus 20, so set them equal to each other. Subtract 2x from both sides, and then add 50 to both sides. You get 2x equals 70, or x equals 35. Now, it told us to find the lengths of PS and RS, so we know that they are congruent. So just put it in to one of them. 4x minus 50, you can use that one, or you can use 2x plus 20. Either one should work. So put in x is 35, 4 times 35 is 140, minus 50 is 90. Okay, let's continue with those. If we're given, let me cover this up for a minute. If we're given that this angle ABD is 2x plus 12 and CBD is 6x minus 18, and we're given this figure, and this perpendicular is important because we measure distance perpendicularly. So from this point D, the perpendicular distance to the side of this angle is the same as the perpendicular distance to the side, to this side of the angle at point C. So AD is congruent to DC. Their measures are equal. So using the converse of the angle bisector theorem, we know that these two angles are congruent. So we can set those expressions equal to each other. Do that, do the math, subtract 2x from both sides, you get 4x, add 18 to both sides, you get 30, divide both sides by 4, and you get x equals 7.5. But it asks to find the measure of angle ABC. Okay, find ABC. Well, ABC is the whole thing, So that's going to be 2 times one of them. So you can choose either one of those expressions to put x into. I chose this one, 2 times x plus 12, but you can say 6 times x minus 18, be the same thing. So 2 times 7.5, which is our x, plus 12 is 27. And then just multiply it by 2 to get the whole thing, which is 54. Okay, that's angle bisectors. Now we're going to talk about medians. Median of a segment, or of a triangle actually, median of a triangle, change that, of a triangle, is a segment from the vertex of the triangle to the midpoint of the opposite side. Okay, so now I want you to stop and draw a triangle, your own triangle. It doesn't have to look like this, it can be whatever triangle you want, and use a ruler and measure. You don't have to construct the midpoint, we're just going to measure. Okay, so this side is 3 inches, so I put the midpoint at 1.5. This side is 4 inches, so I set the midpoint at 2. So just put a little point there. Now use your straight edge and just connect your vertex to the midpoint on the other side to draw your median. So I'll do it here while you're doing it at home. Okay, and again, notice they all intersect at what point? Now the name of this point is the centroid. It's kind of a funny name. But what's cool about it, it's kind of interesting, it's 2/3 the distance from the vertex. So from the vertex, label these A, B, C, and I'm just going to name that O. Okay, from A to O is 2/3 of the distance. Oh, I didn't name these. E. From A to E. Label the midpoints. Okay, so the distance from A to E, A to O, is 2/3 the distance from A to E, which means that the distance from O to E is 1/3 of the distance of the whole thing. Now you have to go from the vertex to the centroid. Okay, so CO is 2/3 of the whole thing of CF. Now if you go this way, it's going to be 1/3. If you go not from the vertex, but from the centroid to the opposite, to the midpoint on the other side. So OF is 1/3 of the total distance from C to F. Likewise, BO is 2/3 the distance from B to G. This is actually, they use this, it's the center of gravity. Maybe if we have time, we can show how you can make a triangle, cut a triangle out of cardboard, find the centroid, and then you can balance the triangle, like with a pencil, on using the centroid, and it will actually balance there. They use this in cars to find the center of gravity. It defines the center of gravity, so it's kind of a cool superpower, even though it might not sound like it. Okay, now let's look at the theorem that goes with it. So we just talked about it's the centroid is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So given this triangle, if we're given that these are all the medians here, these lines, then, and they're indicated, the midpoints indicated by these segments being congruent to each other, meaning that G, H, and J are the midpoints, then we know that the distance from B to N is 2/3 the distance from B to J. And the distance from C to N is 2/3 the distance from C to G. And we know the distance from A to N equals 2/3 the distance from A to H. So that's our conclusion. So we can use that to solve some algebra problems here. Okay, we're given this triangle, and we're given Rx, so this whole thing is 45. then we know that RW is 2/3 the distance of the whole segment, RX. So that's 32. Now, if WX, now that's from the centroid to the midpoint, so that's 1/3 the distance of the whole thing. And if you notice, 16 plus 32 does equal the whole thing, which is 48. Okay, now to find QZ, which is the whole thing, we're given QW, okay, and QW is the distance from the vertex to the centroid. So we know that QW is 2/3 the distance of QZ, and we want to find QZ, but let's plug in what we have. We're given that QW is 30, so we know that 30 equals 2/3 the distance, the QZ. So in order to solve for this, we'd multiply both sides by the reciprocal, 3/2, and that times 3/2. And we would get 3 times 30, which is 90, divided by 2, which is 45. Okay, and WZ, again going from the centroid to the midpoint, is going to be 1/3 the whole distance. Well, we just found the whole distance of 45, so we can just say 1/3 times 45 is 15. Okay, one more. If we're given a triangle DEF with these vertices, 0, 0, E is 3, 6, and F is 4, 0, first we're asked to find the midpoint of DE. Remember our midpoint, don't need a Z. Our midpoint formula is to add the x's, divide by 2, add the y's, divide by 2. Okay, so 0 plus 3 divided by 2 gives us our x coordinate, 1.5. 0 plus 6 divided by 2 gives us 3. So here's our midpoint of DE. Now we're going to use this, and the vertex opposite side DE, well, which vertex is that? If we have a triangle, DEF, and then we're finding the midpoint here, well, the vertex opposite this side is going to be F, and they gave us that point. So we have the point F, and we have the midpoint, so we have 2 points. So we can find the slope of the line. We're asked to find the equation of this median. Okay, so from the vertex F to the midpoint of DE. So first, in order to find the equation, we need the slope and a point to use point-slope formula. So we can find the slope using the difference of the y's divided by the difference of the x's. So the difference of the y's, 3 minus 0, divided by the difference of the x's, which is 1.5 minus 4. So that gives us 3 divided by negative 2.5, and if you put that in your calculator, you get a negative 1.2. So that's our slope. So we can put that into our point-slope formula, y minus y1. We can use this one, or we could use this one, but this one is probably easier. So y minus 0 equals our slope times x minus x1, and there's our x1. Okay, y minus 0 is y. Distribute your negative 1.2, so it's negative 1.2x. Negative 1.2 times negative 4 is going to give you a positive 4.8. And there is your equation. Okay, that is all for this lesson. We'll see you tomorrow.